Okay, so this is day 4 of our worksheet, and so it says there's two terms of the geometric function. We have to find the first, third, and fourth, given the second and fifth one. So as you can see, the fifth one is 25.25, and the second one is 202. So we just divide these two, and we get 1 over 8. And since, 1 over 8 is the difference between these two, we would take the 4 is the term between them, and then we would multiply it, so we get half, so that would be our common ratio. And then using that half, we would just find the rest of this equation. So 202 the second one, and using that common ratio, multiplying it would give us the third term. So we have 202 times half equals 101, so that would be our third term. And then that third term times that common ratio would give us our fourth one. So 101 times half would equal 50.5, which is our fourth term. And then we would take, so we have 50.5 as our fourth term. But to find the first term, we would take the second term and do the inverse of the ratio. So that would be taking the second term, 202 times 2, which would give us 404 as our first term. And then, as I said, the common ratio is half. To find the nth term, we just take the equation, which is nth term equals the first term times the ratio to the power of n minus 1 right here, and we just plug in what we have. So we get nth term equals the a1, which is 404, the ratio, which is half, and then just to the power of n minus 1. So when we plug in any number, we get the nth term. And so that would be our equation right here. To find the 10th term, we just take that same equation over here, and we replace the n with 10 because that's our n. And then we would get 404 times half to the power of 10 minus 1. And that would approximately be 0.789, so that would be our 10th term. And then for the 46th term, we just do the same thing, but instead of 10, we would replace it with 46. We have the 46th term equals 404 times half to the power of 46 minus 1, which is approximately equal to 1.148 times 10 to the 11th, negative 11th power. And so that would be a 46th term. So given the sequence above, determine the partial sum from terms 4 through 10. And so how we would do that using this same function. So we have Sn equals sigma. On the top we have 10 because that's our top sum, and then 4 because that's our lowest. That would equal to the first time, and we use that equation. Previously we have the a1 times 1 minus r to the power of n over 1 minus r, and we would just plug in our numbers. So since it's the fourth term, this is the lowest, we would put 50.5, and then we have 1 minus the ratio, which is half, r, which is half, and then the n would be 7 because that's how many terms there are, and then between 4 and 10, and then we had over 1 minus half because that's our ratio. And then just putting this into calculator, we would have 12,827 over 128, which is which is equal to 100.211. So that would be our partial sum. And then to find the infinite sum, we would take this equation, which is a1 over 1 minus r. So we have 404 over 1 minus half, which is equal to 808, and that would be our infinite sum. So explain why the sequence does or does not have an infinite sum by deductive math reasoning. So we know there is an infinite sum because the common ratio is less than 1, but it's also greater than negative 1. And so that would mean it would start high, but then it would start getting decreasing because the ratio is only half. So and if it was above 1, the ratio was above 1, that would mean it would keep going to infinity and it would never stop. So that would be our infinite sum, would be infinity if the ratio was above 1. But in this case, in this sequence, the ratio is only half, so it would have a stop, and so that's how we got the 808 as our infinite sum. And yeah, that was day number 4.